Hello friends, welcome to Learner's Planet. Friends, this is our fifth session for area, volume and mensuration. In the previous session, we did some basic problems based on 2D and 3D shapes. In this session, we'll be taking some more problems. So let's begin the session. Now let's take this simple problem. The hypotenuse of a triangle is 29 centimeter and one of its sides is 20 centimeter, then the other side is quite a simple problem. We have already discussed the concept of right angle triangle and Pythagoras theorem in our previous sessions. So I would just suggest you just pause the session and try the problem on your own, and that too without paperwork. Okay. You have been given the length of hypotenuse and one of the sides. That means it is a right angle triangle. So definitely with the use of Pythagoras theorem, we can find out the length of the other side, right? Now what will be your answer? That is the other side square will be 29 square minus 20 square. Okay. Now you must be knowing what is 29 square. That is 841. The square of 20 is 400. So the difference is 441. That is the square of 21. So the other side must be 21. Okay, you must be knowing the squares of numbers from 1 to 30 at least. Okay, so I hope you are clear. Now let's see this simple problem. How many small cubes with edges of 10 centimeter can be just accommodated in a cubical box of 1 meter each? In the previous session also we have discussed similar type of problems. It's the game of volume, nothing else. Okay, so first of all you have to find out the volume of this box, and you have to find out the volume of these small cubes. Then you just have to divide the bigger volume by smaller volume. Okay, so number of cubes is equal to volume of bigger body by volume of smaller body. Okay, so what is the volume of bigger body? That is 1 meter. Side is the side length is 1 meter, so volume will be 100 centimeter into 100 centimeter into 100 centimeter, that is L cube, divide by you should be clear that the quantities should be in same units. Here it is in centimeter and here it is in meter. So either both of them in meters or both of them in centimeters. So I converted this data into centimeter. Now 1 meter is 100 centimeter. So the volume of the cube is side cube. So it's 100 into 100 into 100. Now volume of the smaller cubes will be 10 into 10 into 10. So by dividing this by this, we will be getting the number of small cubes that can be accommodated in the bigger box. Okay, so it's 1000. Okay, quite a simple problem. I hope you are clear. Now this is a problem based on trapezium. The perimeter of a trapezium is 52 centimeter and its non-parallel sides are each equal to 10 centimeter and its altitude is 8 centimeter. We have to find its area. Now friends, as I had already told you in the previous session, I will not be drawing this figure over here. You just have to recall the formula for the area of a trapezium. That is half, I just write it, half sum of parallel sides, maybe C plus D, into distance between them, that we can say altitude. Okay, so this is the formula for area of a trapezium. Here we are given the this perimeter and sum and the length of each non-parallel side. That means each of the non-parallel side is 10 centimeter. That means in all the sum of non-parallel side is 20 centimeter. That means sum of parallel side is 52 minus 20, that is 32. And what we need is sum of parallel sides. So I just put it over here. And what is altitude? That is 8. Okay, so it's 128 square units. I hope you are clear. Now let's see this question. The radius of a cylinder is doubled but its lateral surface area is unchanged, then its height must be. Now friends, what is the formula for lateral surface area of a cylinder? That is 2 pi r h. Okay. Now radius is being doubled. That means the new radius is 2r, and we have to find out the value of h, that is the new height, right? So if you wish not to if you don't wish to change the lateral surface area overall, then if radius is double, that means height must be done half. Okay, so this effect will be nullified. As you see over here, this 2 is getting cancelled with this 2. So if radius is doubled, height must be halved. So the lateral surface area will not change. Okay, I hope you are getting me. Now, two cubes have volume in the ratio 1:27. The ratio of areas of one face of one to that of the other is. Friends, quite a simple problem. You don't have to touch even your paper and pen. In volume, the sides are taken in cubical form, right? So that means it is side, this is the ratio of sides cubes. Okay, so S1 cube by S2 cube is 1 by 27. That means S1 by S2 is 1 by 3. Now we have to find out the area of face, that will be in the ratio of S1 square by S2 square, that is 1 by 9. Okay, so for this calculation you don't have to go for any sort of paperwork, right? Just visualize. I hope you are getting me. Now friends, let's see this problem. If length, breadth and height of a rectangular parallelepiped are in the ratio 6:5:4 and the total surface area is 33,300 square meter, then the length, breadth and height of parallelepiped are. Okay, I have shown a parallelepiped over here. See, this is a cuboidal shape, right? Where length, breadth and height, all the three directions, all the three dimensions may be different. Okay, now we are given the ratio as 6:5:4 of length, breadth and height, and we are asked about length, breadth and height. Okay, so further there is no paperwork required at all. You just see among the option length, breadth and height, they should be in the ratio 6:5:4, or we can say the length should be multiple of 6, the breadth should be multiple of 5 and the height should be multiple of 4. Okay, so just keep on eliminating the option. In option A, this 70 is not multiple of 4, so it's incorrect. In option B, 85 is not multiple of 6, so even it is incorrect. In option D, this 80 is not multiple of 6, it's incorrect. In this case, it's 6:5:4 ratio, and you can cross verify it. Okay, so further no paperwork is required at all. You just can do it mentally. Now let's try this sum. Three cubes whose edges are 3 centimeter, 4 centimeter and 5 centimeter respectively are melted without any loss of metal into a single cube. The edge of the new cube is. Friends, further it's quite a simple problem. If these three cubes are getting converted into one single one, that overall volume will not be lost. Okay, so what we have to do is we have to find out the volume of individual cube, then we just have to add, and that will be the volume of the single cube. Okay, so if we get the volume of the single cube, then we can get its length of its edge by taking its cube root. Okay, so what is the volume of this first one? That is 3 cube, that is 27. The volume of the second one is 4 cubes, the 4 cube, that is 64, and this is 125. So 27 plus 64 plus 25, that is the volume of this particular cube. So it's 216, that is 6 cube, right? So volume is 6 cube, that is side cube, so side will be 6. That means the edge of the new cube will be 6 centimeter, right? It's very simple. Now let's see this question. A metal sheet 27 centimeter long, 8 centimeter broad and 1 centimeter thick is melted into a cube. We have to find out the difference between surface areas of two solids. Now friends, when one body is converted to the other body, then volume is not changed unless until it is specifically specified. Okay, So in this case, it's nothing is specified. That means we have to assume that the volume will be same while we are converting this metal sheet into this cubical shape. Okay. Now suppose this is the metal sheet. If this is length, breadth, I'm sorry, this breadth, and this is maybe height, or maybe we can say thickness. Okay. Now what is the volume of a cuboid? That is L into B into H. Okay. Volume of cuboid, right? So it's 27 into 8 into 1. So volume of cube will also be same. So that is 27 into 8 into 1. That is volume of cube. So side of cube will be cube root of this. So it will be 3 into 2. That is cube root of this into cube root of this into cube root of this. So side of the cube is 6. Okay. Now we know the side of the cube. We know the sides of cuboid. So we can calculate their surface area. Now what is the surface area of this cuboid? Maybe if we talk about this metal sheet. So it's twice L into B plus B into H plus L into H. Okay, so this is what the surface area of this cuboid. So just put the value, that is 27 into 8 plus 8 into 1 plus 27 into 1, right? So it's, after calculation you'll be getting it to be 502. Now what is the surface area of this cube? That is 6 into side square. So 6 into 6 square, that is 216. So the difference is 502 minus 216, right? Okay, I hope you are clear. Now let's try this problem. ABC is a right angle triangle with the angle BAC is 90 degree. That means this angle is 90 degree. AH is drawn perpendicular to BC where H lies on BC. If AB is 60 and AC is 80, we have to find out the length of BH. Friends, it's quite a simple problem. I can explain you it without even the use of paper. So just listen to me carefully. Then I'll explain you how to do the problem in formal manner. Okay. First of all, just it is 60, 80, and that means it must, the complete length must be 100 because it's already given also. And if it is not given, then also you just can calculate because 60, 80 and 100, that is 6, 8 and 10. These three numbers are making Pythagorean triplet. Okay. Since this is 90 degree angle, so 6, 8, 10 are making Pythagorean triplet. That means 60, 80 and 100 will also be in Pythagorean triplets. Okay, so this is 60, 80 and 100 is the length of BC. Now we have to find out the length of BH. Just listen to me very carefully, right? Now what is the area of this triangle? That is half of 60 into 80. That is half of base into altitude. Okay, so it's half of 80 into 60. That means half of 4800. That is 2400. Okay, so that is the area of this triangle. Now we consider this as a base and this as an altitude, then also the area will remain same. Yeah, and the area is 2400. Now the base is this, that is BC, that is 100 into altitude is AH and divide by 2, right? So AH is 48. Okay. Now this is 48. If I divide it by 12, what I'll be getting? I'll be getting 4. If I divide this by 12, I'll be getting 5. So it is 3, 4, 5 Pythagorean triplet because it is also an altitude. Okay. So it's 4, 5. So it must be 3. And actually the length is 48. That is 12 times 4. So this length will be 12 times 3. That is 36. I hope you are clear. So I don't think much paperwork is required. Okay, if you know about Pythagorean triplets in a well manner. Okay, so let's move to the another problem. A right cylindrical vessel is full with water. How many right cones having same diameter and height as of right cylinder will be needed to store that water? Now, what is the volume of a cylinder? That is pi r square h. And the volume of the cone is 1/3 of pi r square h. Now, since diameter and height, both of them are same, so it's volume of cylinder and its volume of cone, so it's 1 upon 3 pi r square h. I'm using r and h both same as well because radius of a cylinder and cone and height of height of both of them is also same. Okay, so you can see that the volume of this cone is 1/3 that of cylinder, so you need 3 cones to store the water. Okay, I hope you are clear. Now let's try this problem. In the given figure, RSTV is a square inscribed in a circle with center O and radius R. The total area of the shaded region is. Okay, so we can see that the complete region is circular region, and inside the circle there is a square region, and we have to find out that area of this green shade. Okay, so it's quite simple problem, friends. You just take the area of the circle, deduct the area of the square from it, so you'll be getting the area of the remaining portion, that is the green one. Okay, so what is the area of the circle? That is pi r square. Now what is the area of this square? Now this complete length is 2r, isn't it? And this is the diagonal of this square. Now this is 2r, this is x I suppose, and this is x I suppose. Okay, because these two lengths will be same. Okay, so x square plus x square is equal to 4r square. Okay, this is the Pythagoras theorem I'm using. This is hypotenuse, this is perpendicular, and this is base. Okay, so 2x square is 4r square, so it's 2. Okay, so area of this square will be x square, and x square is equal to 2r square. Okay, and now we have to find out the area of the shaded region or the green region. So that is area of circle minus area of square. Okay, so it's pi minus 2 r square. Okay, quite simple. Now let's try this question. A square garden measuring 8 meter on a side is surrounded by a 1 meter wide path. What is the area of the path? Now this is the square garden, and that is the side of this is 8 meters. Now the width of this path is 1 meter. Now we have to find out the area of this path. Now if this is a square and this 1 meter, its width is same on all the sides, that means this outer body is also a square shape. Okay, now if we wish to find out the area of this path, we should find out the area of the outer square, then we can deduct the area of the inner square, so we will be getting the area of the path. Now the dimension of the inner square is 8 meter, so the dimension of the outer square will be 8 meter plus 1 meter this side and plus 1 meter this side, so it's 10 meter. Okay, so area of outer square will be 10 square, that is 100, and area of inner square is 8 square, that is 64. So area of path will be 36 square units. Okay, I hope it's simple. Now friends, let's discuss some problems based on percentage and mensuration. Okay, so here what happens, there are different types of functions. I have discussed the same thing in my percentage sessions also, so you can refer the same from there also. Once again, I'm just repeating the things and repeating the concept over here for simplicity. There are various types of functions, maybe linear, quadratic, or you can say second degree, cubic, and more of them. Okay, now what is happening ki whenever you are asked to increase or decrease the side or maybe radius of a 2D shape or maybe a 3D shape, so what will be the change in respective area or maybe volume or maybe perimeter, something like that. So we are going to discuss this sort of problem now. Now, now the most important thing over here, so whenever you are dealing with mensuration percentage problem, if final answer is in percentage only, then you are not in requirement of any basic data. That means actual dimensions are not at all required. You can deal with percentage only. Okay. Now, first of all, let's see the simple question, and gradually I'll be explaining you the entire concept. The length of a rectangle is increased by 20%. By what percent should the breadth of the rectangle be decreased to maintain the same area? Okay, first of all, let's begin to do. What I assume, the rectangle's initial length is 10. Okay, initial breadth is also 10 and initial area will be 100. Now length is increased by 20%. As I already told you that if you are dealing with percentage, no need to worry that what are the basic values. Okay, even if it is a rectangle, I can take the dimensions as same. Okay, doesn't matter while we are calculating the answer in percentage. Okay, so length and breadth, both of them are 10 and the area will be 100. Now length is increased by 20%, so length will be 12. Now we don't know the breadth. I just write it, the new breadth, as B over here. And what we want, the area to be same. So it's 100. So what is B? That is 100 by 12. Okay. That means the new breadth is 100 by 12. That is 425, 43, that is 25 by 3. So initially it was 10, now it is 25 by 3. So what is the percentage decrease? That is 10 minus 25 by 3. And from what the percentage decrease is there? It's from 10 and it's 100. So it's 30 minus 25, that is 5 by 30 into 100. So it's 50 by 3%. Okay. So that's none of this over here. I hope you are getting me. We'll be taking some more problems. Now let's try this question. If the diameter of a circle is increased by 25%, find the percentage increase in circumference. Further, quite a simple problem. What is the formula for circumference? That is 2 pi r. Okay. Now r is a linear function over here, or we can say the power of r is only 1. Okay. So in such cases, when the variable is having linear power, so whatever the increase in that particular variable, the same increase will be there in the this particular dependent variable. Okay, so here radius is increased by 25% since diameter is increased by 25%. So as the circumference will also increase by 25%. Okay, no need to calculate. Okay, but if you are asked about the area, then there will be a change. And what that change will be? See, initially suppose area is, the formula for area is pi r square. Pi is a constant, so I want calculated. Maybe initially the radius is 10 and 10. So initially the area is, the basic area is 100. I'm just not calculating the pi because it won't create any difference in while we are just seeing the percentage change. Okay. So its radius is 10 into 10 and the area is 100. Now if the diameter is increasing by 25%, that means radius is also increasing by 25%. So what will be the new radius? That will be 12.5. This is also 12.5. So in all it will be 156.25. Okay, so what's the increase? It's 56.25%. Okay, so if you are asked about the percentage increase in circumference, then it will be same, that is 25%. And if you are asked about percentage increase in radius, then it will be 56.25%. Okay, I hope you are getting me. Friends, mathematics is an essential part of our everyday life. We come across various situations in our day-to-day life when we are dealing with the mathematical problems. I just take a practical case of a restaurant. Okay, in a particular restaurant, maybe it is selling pizzas. They have certain fixed rate for pizzas. Suppose this is the smaller one having radius r, and they sell that pizza is for 40 rupees. Okay, now suppose they have other variety of the pizza of the double the radius 2r. Okay, now these people are selling this particular pizza is for 80 rupees. Now most of the students, they understand that if the radius is doubled, the size is also double, so the price which is getting doubled is valid. So it's making no difference. but actually it's not happening. What is the difference that you just try to understand? Now this is R, so the radius will be radius is r, so the area will be pi r square. Okay, so for pi r square you are paying 40 rupees. Now in this case the radius is double, that is 2r. So what will be the new area? That is pi into 2r square. So it's 4 pi r square. That means now the new area is 4 times. Okay, and the price is just getting doubled. So as a customer you will get benefit if you buy this pizza. Okay, so in examination timings also you are asked such problems. If the size is doubled, what would be the impact on the customers, or and maybe who will be getting the benefit, maybe the restaurant or the customer. Okay, so it should be clear about this thing. If radius is getting doubled, the area will be 4 times. So just relate the price. Okay, I hope you are getting me. Friends, I hope you might have enjoyed the session. We'll be taking more such problems in our next session. Do revise this session and the previous ones of mensuration, and see you in the next session. Bye bye.